Yo, what's up, everybody? Welcome back. Today we are writing a debugger, because I was Googling how do debuggers work, and the answer seemed like it fit perfectly for the type of like fun little low-level thing that ends up getting done on this stream a lot, and I wanted to try it and see how it works. So, um, okay. So context is you have some source code, right? You run your executable and you click the little button, and you get a little red dot here, and you want the program to stop executing here. If you're like in like JavaScript or like Python or like an interpreted language, this seems fairly straightforward, right? You like integrate with the interpreter somehow, and the interpreter says like, "Oh, I have to stop at this spot." That's like, I don't know if that's how it actually works, but that would be like, that doesn't seem crazy to me. What seems a little bit more crazy to me is like your source code gets turned, when you're working in like a lower level language, gets turned into like assembly, right? So you have like, you have like add R1, R2, right? And like, then if say you want to stop on like mul, and then there's like another like add or something, right? This is like just kind of like run directly on the CPU. And so how do you make it stop when it gets here? And it turns out, as far as I understand, the answer is that you look, when you like load your process, you have like memory for that process, right? Like this is like memory. And these things just are like opcodes. These are just like hex things in here, right? I don't know like what they are, but it doesn't really matter. And what you can actually do is, since this is just like stuff in memory, and when you're executing this thing, you just have like a program counter, like a register that's pointing to like where in memory you're executing. You can just kind of like take this mul and just like delete it and replace it with like stop please. And all that you have to do there is just like swap out a single byte in here. And then I assume that like somehow this has to like give control back to some other process. There's some intricacies here on like a process needs to be able to access and modify the process of the memory of another process, and then as well we kind of have to be able to continue. We have to be able to say, okay, so when we hit this stop please, we need to put the multiplication back, and then step one instruction, I think, to get to the next thing, and then put the breakpoint back. That's my guess on how I would implement this. I only looked up enough to know that you have to do this like instruction swap to do stop. And so the other component here is, you could do this from like your own binary, but if you're attaching to like a debugger, you need to modify a memory of another executable. And so there's this Linux kernel API ptrace, and this basically like gives you all of the tools that you need to implement a debugger. And so I don't know if you guys have ever tried to like attach to running processes in Linux. If you tried to like gdb-p and like punch in a process ID, it'll go, whoa, dude, you need to like enable this kernel feature that says like, trust me, bro, I'm okay with this. And after reading this man page a little bit, I'm like, oh, I get it. Because this ptrace API just lets you basically like do whatever the fuck you want to any other process. I guess probably within some form of like permissions, boundaries, or whatever. But like you can just like, mess that other process up. And we can use that to say, I would like to modify the binary, please. And so I think we want to play with this and see if we can make this work. So what I want to do is I want to first try this like trap instruction that you're supposed to swap in. I think I saw Wikipedia. Oops, I don't know. Don't take me to Amazon. Ew. Wikipedia int x86. Here they talk about this like int3 instruction, a 1 byte instruction defined for use by debuggers to temporarily replace an instruction in a running program in order to set a code or breakpoint. So I want to see what happens if we just do this like in a process without ptrace. If that gets us into the signal handler, then like things kind of make sense to me. We kind of continue on. Then we can like create a ptrace executable, try to breakpoint by address, try to implement like continue, and then maybe try to figure out how we like correlate which breakpoint we actually hit by looking at like the program counter probably in the child process. And then maybe if we get through all this and we like happen to rip through that way too quickly, we can look at like parsing like elf headers and trying to figure out which, like, breaking by function name, so which address corresponds to which function, and maybe we can try to break the point by that. But I think it's more likely that we'll just kind of do this stuff. Yeah, and let's jump in and see what happens. So we're at 5 minutes. So we are at 5 minutes and 10 seconds, and we are starting to try the trap instruction. What's the difference between strace and ptrace? They're like totally different things. Strace is like, I would like to watch system calls, please. And ptrace is like, I would like to poke and prod this other executable. If I understand correctly, but I might not. Okay, so let's do make dir source and edit source main.zig. And let's just kind of see like pub function main void. And let's do something like, we have something, so import std, and we'll do like, let's log something. So say like, hi, hello world. And I guess we will set up our build zig as well and say we have some pub function build, which takes in a builder, which is a std build, I think. Not std, import std. And we need to build our executable. So b add executable of with the file we just made. So source, was it main.zig? I can't remember. And we need to set like a target and an optimize level, if I remember correctly. And so now we need to be like const target is a b standard target options. And optimize is standard optimize option. All right. Then what? We b install artifact of exe, and we should be good to go. Oopsies. Zig build. Not quite. Missing field name. So the name is equal to, we'll call this dsphero because my name is from a bug. And so we can say that we're debugging. Debugging. Stupid fucking. It's fine. Okay. So we got hello world. And now we can go, get init, or else my search for files doesn't work. And then in here, maybe we do something like goodbye. And in the middle, let's just shove an int 3 and see what happens. Did I build in debug mode? Yep. Debug by default. So is there like zig inline ASM? I assume there is. ASM vault. Okay, so how can we just like, is this like documentation? Here we go. This is more what I want. Okay, so assembly, directing the syntax. Oh, geez. So this is just similar to any ASM block where you have the text with the output, constraint, inputs, clobbers. Okay, so can we just do this? There's also at trap. Oh, okay. Well, let's do this first because I just want to see, but it would be good to replace with the trap later. All right. So that did something. That did something. That's good. So it looks like the Linux kernel notices that that happens, and he says, I will crash you now. And I wonder, is that like a signal that can be intercepted? Is there like, is one of these sig trap? Ah, there is. Okay, so we should, if I understand this correctly, be able to add a signal handler that watches for sig trap and log it instead of crashing. And if that is true, then we kind of understand how this is hooked up. I guess we are kind of assuming that there's some Linux kernel shenanigans that catch this interrupt and forward it to the correct process, which maybe we wouldn't understand perfectly, but that's okay. So I think you have like, how do we like do signal handlers again? Linux signal handler. It's been a second. Does this have an example for us? No. Signal 2. ANSI signal handling. Example? Really? No. Sig action also sounds familiar. Example. I just want somebody to tell me what to type. Here we go. This looks like what I want. So they're saying we have some actions. So stood OS, I think Linux probably, sig action is the structure here. So var act is equal to the action. Then we set our flags and our handler. I don't know what these flags are. We can look at them, I guess. SA sig info. Then it uses action instead of handler. I see. Okay, so he says use the action thing. What's SA unsupported? Used to dynamically probe for flag bit support. I guess I don't really care. And what is this? Normally when delivering a signal, an architecture-specific set of tag bits are cleared. I guess I don't care. I really don't care. So if this is given, I use sig action instead of handler. Which one of these is easier? I do just want handler function probably. So I think we just set the action dot, was it flags to 0? Which it probably is by default, to be honest. Oh, it's not set at all. So this is probably just not going to compile. So we set the flags to 0, and the handler is equal to handler of signal handler. All right. And then that just means we need to implement this. So this is function handler, signal handler. Sorry. How does this work? Like this, I guess. And here we have the num, and then can we just like print the number? Got signal D. But the handler should be in the debugger, not the debuggee. Yeah, but I want to just experiment. I just want to make sure that I understand what's going on first, and then we can move on to doing that. Let's see, OS sig Linux sig action. I think we want POSIX sig action. There we go. So we want stood OS Linux, and we want signal trap. We believe that we can block this with our action and null, I guess. And try this. Then run int3. And if everything is working the way we expect, then we should get got signal this thing from our signal handler. But instead, we are missing the field mask. So what did they do for mask? They just set to 0 as well, I guess. He's mad. He's mad. What's supposed to go in this mask thing? Sig set T. What's this? Probably just all mask, huh? I don't know, but why not? He's mad because I forgot an A in mask. All right. He built. Okay. So now we have successfully trapped that signal, printed it instead of crashing, and so I think we understand that if we are to put an int3 somewhere, that turns into a user space sig trap. Perfect. So I think that gets us out of like step 1 of this thing, and now I can kind of move into step 2, which is let's try starting something with ptrace. So I guess we will actually call this thing that we're running, we will turn this into like the debuggy, right? And we'll call this debuggy. uh-huh. Source, and we'll call this debuggy.zig, and then we will make source. All right, hold on. Delete this. Open debuggy, and then edit source debugger zig. Okay. So here we are going to run the debuggy. So let's just start with execing that thing. So const_stud is equal to import std. And let's just do stud posix exec. I don't know which one of these we want. I can't remember. VP gives me argv pointer versus child argv. What's the difference between these? I can't remember. Exec VP. Exec VE. Man exec V. No, do I want like C also? Where's like my list of the differences between them? Exec vep. Exec vep VP. What was it? Exec P? I already forgot. This goes to what eventually under the hood? Oh, this is just except if arg0 is expand, then argv is mutable. Expand to be the same absolute path that was past the exec ve syscall. Right, so he's just calling exec ve under the hood. So we just want exec ve. I guess. So we want the path to the thing to execute. So zig out bin debuggy. What else has to go in here? Child argv is a null terminated list of strings. So we just want to pass in like an immediate null. We have no arguments to pass in, please. Unless we need to pass in the process name, which we might have to. But we can come back to that. And then mp, can we just pass in null? Is this allowed to be null, or is that going to get mad at me? Is that going to get mad at me? Who knows? Okay. Build.zig. So we need to build the debugger as well. We need to build the debugger as well. So we just do this again, but for... and then this should be debugger, and this should be debugger. All right. So yeah, he needs that to be an immediately null terminated list as well. He needs it like this. Expected error type found blah blah blah. Wait, what? Main void. Expected error union type found error this that. Am I stupid? Debugger expected error union type. Is this not an error? No, it is. Like, am I... Yeah, error set is discarded, right, of course. So if I do this, is that fine? Okay. Okay, so calling debugger, it looks like we got signal 5, and if we say stood debug print hello world, before execing, we are probably also fine. Yeah, okay. So it looks like we have correctly launched something, and now I guess we need to fork before doing that. So stood. I don't understand why this didn't work though. Like why I'm so lost here where returning an error here does not work. Like there's something expected error unit type found. Yeah, I'm just very, very confused there. If I say like stood posix exec ver, yeah, it's super strange. Reference by call main. Can we like look at this and just see what the fuck this is doing? Call main. So he was saying at line 524. So here he catches an error. He calls root main, catch error. I don't really see a problem there, to be honest. Don't see a problem there at all. Oh well. I guess we'll just, let me just double check that like another error type doesn't cause this problem that we've seen before. Like try std fs currenter create file test text. Right? Like this has always worked. Then discard f. He does expect 2 arguments. That's a good point. Yeah, very strange. Very strange. So specifically this stood posix exec ve. Oh, probably because this guy fucks stuff up. Right? Like he replaces the return value with like the return of his child or something. So that might like fuck shit up. Okay. Let's just ignore this for now and we'll do like a fork and exec now. So stood posix fork. And this returns, if I remember correctly, something on if I'm the parent or the child. Something if I'm the parent or the child. So if I'm the parent, I get, if I'm the child, I get 0. If I'm the parent, I get the PID of the child. So, okay, we'll try get const PID, so we'll try this. And if PID is equal to 0, we do this. Log error, exec error s with error name of e. Else, I guess return for now. He's mad because the fuck? Why is this happening again? Huh. All right. Whatever. So we're on the debugger. See stood debug print exiting parent. I guess. Just to prove that we have successfully bisected. Chillin'. And then now we have to like do some like actual work here. So if I look at man2 ptrace, what are we supposed to do here? What are we supposed to do here? I was reading that the child process is supposed to call ptrace trace me. Okay. And he says that basically I'm allowing somebody to trace me. Then I guess the parent is probably supposed to like attach this guy. So attach, I think. Attach to the process specified in PID, making it a tracee of the calling process. So making it a tracee of the calling process. Whoa. Attachment process in PID, making it the tracee of the calling process. The tracee is sent to sig stop. Oh, PID is the tracee. Okay, that makes more sense. So yeah, I think that like we just say trace me from the child before we exec. Then we trace from the parent and just kind of see what happens, I guess. Yeah. Stood POSIX ptrace, and we say stood OS Linux probably ptrace trace me. And then were we supposed to provide any arguments there for ptrace trace me? PID, adder, and data are ignored. So no, we don't. We just say, please trace me. So here, I guess we just say undefined, undefined, undefined. Seems fine to me. Okay. He gets exiting parent, and weirdly, it looks like when we say ptrace trace me. Oh, maybe we're just racing here. Stood time sleep for 1E9. Let's sleep for 1 second here before getting crazier. Okay. So it looks like we're pretty consistently not running the child here, which I guess is an artifact of running trace me here. Yes, okay. That error is strange using 013. Yep, 013. So I suspect that this actually says, hey, I'm going to stop execution until I'm attached to. That would be my guess. So if we do this and we say stood POSIX ptrace, and we say, can we please attach to that process? CSC0, thanks for the prime. Much appreciated. And I assume that we pass in the PID here. And what else goes in here? Attach. Attach. Stop. Okay, so adder and data are ignored. Okay. Undefined, undefined. So here, do we expect to see different behavior? So no, still nothing happens there. It would actually be interesting here to do stood debug print about to exec. Let's see if we actually get here in this case. Nothing. Need to wait PID? Who does? Man to ptrace. Is there an example in here? Is there an example? There might be, but there might not be. In which case, we will figure it out. We could just Google as well. How the fuck am I supposed to do this? Because a wait PID does seem reasonable. Ptrace debugger. Isn't that the wrong PID you pass to attach? I don't think so. Here we are in the child. Otherwise, we get the PID of our child, and we're trying to trace the child, I think. Maybe I don't understand. Does this guy just have the answer in here? ptrace. System call, blah, 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 blah. Ptrace, trace me, example. You're saying that I'm supposed to wait PID on the parent. I think that it's not happening though. Oh. So maybe you're saying that this is like it knows. Okay, what does that do? What does that do? Man to wait. Suspends execution of the calling thread until one of its children terminates. Yeah, but I'm not waiting for it to terminate, I thought. But I mean, this guy is doing it that way, so there's a reason. While being traced, the tracee will stop each time a signal is delivered, even if the signal is being ignored. The tracer will be notified as next call to wait PID. Ah, I see. So I wait for the tracee, then I must I say, okay, you can keep going now. Right. So I do like while true, or I guess here I don't need to do, well, yeah, while true, stood POSIX, wait PID, given PID. And then here, wait PID is asking for some flags. What are the options for my flags here? Options, W no hang, W untraced. Also return if a trial has been stopped but not traced. Seems fine. Okay, what else is in here? Trace. It looks like W untrace is special. So if I don't pass in anything, I expect to get what I want, I guess. And this will return me a wait PID result, which gives me a PID and a status. So can we get like ret is equal to this, stood debug, print, wait PID res is any. And then I guess we just do that in a loop forever. I mean, eventually this is going to give me something else. Where does the status come from? Wait PID. Right, so the status is, okay. The value of PID can be these things. What about like the output of the status? If W status is not null, store status information. The integer can be inspected with the following macros to see, which take an integer argument, and they will tell me what state this thing is in. I see. So we probably want to say, we're probably looking for whiff stopped. And anything else is probably like time for us to exit. So we're looking, whiff exited. So if it exited, we break. Or it exit status. We probably just want to not break if it's stopped. So is there like stopped? Is that like a thing that I can do from here? Like W, I have stopped here. Okay, stood OS Linux. We're looking at OS Linux. W, stopped. So if this ret status, we break. Otherwise, we got this. Zig build, hello. He's mad because comp time int is not a function. Oh, I have stopped, sorry. Okay, exiting parent, about to exec. Oh, oops, if this is not stopped, we break. My bad. So we did get, we need to also continue. We need to say, hey, bitch, keep going. In this case, we need to say, keep going. And does that have arguments I'm supposed to pass? If data is non-zero, it is interpreted as the number of a signal to be delivered to the trace. Otherwise, no signal is delivered. Adder is ignored. Okay, so here I actually need to put this as 0. And then we should see him just kind of keep going, but he's not keeping going. He's not keeping going. So what up with that? What up with that? We're also not seeing this at all. So there's a lot of things I'm confused about here. We wait, we got a result. It would be interesting to like get debug information about the thing we got out of here. It's also kind of weird that like we're never seeing this, right? Like it seems almost like this is hanging. Conch should be outside. That's a really good point. It's a really good point. But then we're getting permission denied in POSIX ptrace. Oh. That's interesting. Why is that? Why is that? So ptrace trace me eperm. Ptrace is limited. The system call is limited to one tracing application per process. Insufficient privileges. The required capability caps as ptrace is unprivileged processes cannot trace processes that they cannot send signals to. I thought this was a way. No, because I can GDB stuff. So how come I can GDB stuff, but this doesn't work? Hold on. Debug. So we do have several debuggers open here apparently, which I wonder if that's related. Like, where are those coming from? Can we sig kill these? Okay, that's good. Okay, so they're all, we don't have anything like hung up anymore, but I don't understand still why this is now failing. We did see it working at some point before, I feel like, but I'm not sure. Okay. So if I just don't try there, does it work? Like, if we just don't do a continue here, how do we test that? We can test that by just commenting this out, I guess, or we just don't do our continue. Yeah, here we just don't do the continue. We don't see the child advancing. But if we do the continue, then we do see the child advancing. So it looks like it's like the error reporting here is just not quite working correctly, because if we write try on the ptrace here, he gives us an eperm, but like it's clearly working. So like fuck it, I guess. We'll just note like getting eperm here. Getting eperm here, but seems like it's working, right? Like if we do this, we just don't run that at all. And then we don't run continue here. Oh, we see the same behavior. So it could be that ptrace trace me requires something. I thought that ptrace trace me was supposed to say like stop me off rip. But maybe not. Try adds another level of complexity. How does try work? Well, it just try is just like a fancy way of saying like return error if you get an error. It's possible that like GDB has the ptrace thing on it. So this is the executable, and can we like get caps on exe? Linux. Get pcaps. No, I want to know like there's a way to like say that you have like specific permissions for this executable, and I can't remember what it is. Linux set capabilities for executable. Set cap looks promising, which I assume comes with a get cap. Yeah. Which is returning nothing. Man to ptrace. eperm. Specified process cannot be traced. This could be because the tracer has insufficient privileges. The required capabilities caps as ptrace. Unprivileged processes cannot trace processes that they cannot send signals to, or those running set UID or set group ID programs. Alternatively, the process may already be traced. Can we look up like ptrace trace me eperm? Like, I just don't understand. I don't understand. Maybe we look for an example again. Playing with ptrace part 1. Blah, blah, blah. So he does exactly what we were doing. Ptrace trace me. Oh. Maybe we need to pass a 0 in here? Seems possible. Although it said it was undefined, but oh. We can try it. Why not? Yeah, still permission denied. So yeah, he's all just doing ptrace trace me. I guess he's also not checking the return though. Garbit, thanks for the prime. Could it be something with proxys kernel yamma ptrace scope? I would think though that given that GDB works, I would think not. But it could be. Child of ptrace with the first argument equal to ptrace trace me. This tells the kernel that the process is being traced when the child executes the execv system call and hand control back to the parent. It's weird to me that this is just kind of working. Right? Like, well, I guess we don't really know that because we haven't called attach yet. This also doesn't have to call attach from this guy's example. So if we do this with no trace me at all, oh, oops, here, with no trace me, okay, everything just goes. Now here, we throw in a trace me. It hangs. Oh, I wonder if it's erasing the attach from the other thread. Yeah, okay. So we thought that we had to attach here, but the attach kind of implicitly happens if we write trace me, I think. I actually think that's the case. It's from The Room, I think. Right? That weird guy goes, when he tries to laugh. Okay. So that makes sense. It's either you attach or the child says trace me, which is fine. Okay, so we kind of have the piece of run the executable. And let's try to like set a breakpoint. So I think here we basically want to probe the memory of the thing and replace the contents of some address after exec with the int3 instruction. Legit, the only stream I don't turn off when I get a 3-minute ad. Easy sub. Hey man, appreciate that. Okay, so wait, let's go back into our debuggy, and here we'll turn off our signal handling stuff. Not that it should matter, but it will make it a little clearer. And okay, so I guess we want to flag somehow that something is happening. So we kind of want like a nice little entry point probably, so that we have something to uh like latch onto in our obj dump. So can we say that we have some function that's like do goodbye? Okay. And he will do the goodbye. Okay. Might be fun to just change the child messages for starters, but those strings are status or static. I think I'm okay with just doing like the breakpoint swap. I think it'll work. I think it'll work. So what I want here is here I want to print out. Oh, maybe before here actually, it might make sense to log the program counter so that we know where we stopped from. So I think that's a thing we can get from ptrace. We can ask for like the registers, get regs. So copy the general purpose or floating point registers to the address data in the tracer. So we wait, shit, I forgot. Oh god, get regs. See sysuser.h for information on the format of this data. So we should be able to do something like, first of all, let's see, does Zig have like man sys user man? We can always do like include sys user, but I want to know if this like has it. Which would be in like OS, probably Linux, and user. Yeah, it doesn't really look like it. User description, entry number, base adder, limit. Anything else that looks kind of promising? I guess we should look at what's in there. So can we look at can we do like a debugger? We will do our C import. I know it sounds the same, but you could have the manual open another tab. Shut the fuck up. I'll do what I want. So that compiles actually without linking libc, which is kind of interesting. Oh, but maybe only because I'm not trying to use it. So can we do like c dot struct user? Oh hell yeah! Wait, this actually looks promising. Yeah. So it looks like actually weirdly that we don't need to link libc for this to work, which is kind of nice. So here we'll do like var user data is equal to this. Alacrity doesn't have tabs. It actually has lots of them. It has splits too. I'm just a fucking idiot. And then here, let's do get regs. And we put the user data in data, it said, which is not adder. So it's this one. And then here we should be able to say that like program counter at user data dot. Surely one of the things in here is a program counter, right? Regs. Instruction pointer, RIP, I think. I'm pretty sure RIP is the program counter. Pretty sure. Regs RIP. And let's see what happens. He's mad. C import failed. Fuck. Sys user.h not found. Fuck. Maybe we do have to link libc. Expression found. What's he bitching about? He's just a whiner. Confused little whiner. Expected use size found pointer. So I guess we just do a bit cast here. Cannot bit cast? Int from pointer. Fine. Fine. If that's what you need. Okay. Program counter at so clearly this didn't work. Which is surprising. Copy the trace's general purpose or floating point registers to the address data in the tracer. See sys user.h for information on the format of this data. Adder is ignored. Maybe it's supposed to not be. I mean, it's the first element in the struct. So even if it was supposed to be the reg struct and not the user struct, it's like the first thing in there. So why is this not doing anything? This is adder signal, which maybe is not matching the names from the ptrace syscall. PID adder data. PID. Whoa, wait, what the fuck? Request PID adder signal. Yes, they're passing signal as data, which they're saying here. They're saying adder is ignored and data is where the data goes. So I don't really understand why. Get reg set. Read the traces registers in an architecture dependent way. Okay, but like, so get reg's not working? Not modifying data. Like, okay, that's not helpful. This also maybe not helpful. Can we look at like a ptrace get regs example? Fuck. Like, are we doing something? I mean, he does use the struct regs instead of what we did, but I don't see why that should matter. Right? This should be like reg user reg struct. This should be the same fucking shit because the pointer lines up. It was the first element, so I don't really see why this would be different, but we could try. Oh wait, the process specify. Oh wait PID. Wait PID process specified does not exist. Oh, because the parent died probably. There's probably some like. No, I'm actually confused. Oh, wait. Why is it just fine now? I'm confused. Okay. I just put a new line in there and that changed the behavior, I think. Right, this was no good. This was fine. Oh! No, I'm not seeing it. Weird. But I guess maybe fine. What the fuck? I don't really have a good answer for why that's changing behavior consistently. The other thing that's going on here is it's actually printing it twice in this scenario, right? It's saying that like the process is dead, which also makes sense. Oh, I wonder if like no, because here we're saying like we called wait PID, the PID is stopped because otherwise this would return true. And then we call get regs and then continue. I don't know. Unless unless it like auto continues. Race and backslash n flushes. It does feel like that, huh? but I just don't understand why. I'm gonna ignore the problem for now, with the knowledge that we could be doing something majorly wrong, and just kind of continue on for a little bit. So now I think on the first run, we want to, well, I guess let's first start and look at like what the fuck is this thing that's coming out. This should be the entry point of the program if I understand correctly. So if we do readelf.-h of zig out bin debuggy 034500 034500. So yeah, that is the start point, which is pretty cool. And so yeah, I guess we can do like if we get the program counter regs rip is equal to this, then we can do like initialization of our other breakpoints. So here we'll say initializing breakpoints. Okay, and so now we need to set some data. We basically have to like replace instructions. So let's start with zig build obj dump -d of oh wait, we've made it a function, so we can just do nm-c of zig out bin debuggy and look for goodbye. So we have this address do goodbye, and we should be able to like replace the first instruction at this address with a int 3. So let's just, I think it's like ptrace poke text or ptrace poke data. So can we like get peak text and peak data, get a word at the address in the trace's memory, and poke text, copy a word back. So if we're trying to swap out the first instruction, we should get the word, set the lowest bytes to 0xcc, I think it was, from that Wikipedia page, 0xcc, and then if we don't make any attempts to put it back, we can continue running, and we should see that we get we at least will see that trap trigger at that program counter. I think that's what I expect to see here. So let's do a ptrace peak data at, or peak text, I guess is slightly more correct, at address. So that goes here. I guess here we could maybe pub function set breakpoint. Fuck it. We'll split it out later. Const start addy is equal to this. Let's at least start naming some of these things because they're going to get a real problematic really quick. Const breakpoint addy is this. Okay. So we get the thing. Doesn't the data, oh, peak data probably returns it into data, probably. Returning the word as a result of the ptrace call, data is ignored. Okay, so I was wrong. So this, we don't have a way to return from here? Which is kind of odd. Kind of makes me think that this isn't working correctly. Right? Oh, wait, on Linux, maybe it's different. Yeah, I mean, it looks a lot like we're just not going to get the data back. It has to go into data, right? But see notes. Okay, let's look at notes. Although argument blah blah blah. Although arguments of ptrace are interpreted according to the prototype given, glibc currently declares ptrace as a variadic function with only the OP argument fixed. It is recommended to always apply 4 arguments. Okay. None of this looks like relevant to the thing that it was talking about, right? Data is ignored, but C notes. Oh, but maybe they do that for all data is ignored. Adder is ignored. Yeah, I don't understand. Linux don't have a separate text and blah, blah, blah. Okay. So ptrace returns a long. And so I guess it's kind of arguing that it can't fail? So, like, if the address there is like, if we are getting a 64, oh wait, what's the size of a word? Maybe that was the thing that they wanted from notes. Notes. Okay. The size of a word is determined by the operating system variant. So for 32-bit Linux, it's 32 bits. So is long? It's possible that maybe because of the return type, it will kind of hide the error. Like, how do I say this? If we have like long, it's like word goes here, and then if this will be negative over here if it's an error. And so maybe you can kind of pack both things in there, depending on if word is like, if long is longer than word, you know? I guess we'll just try it and see what happens. So let's just try peak data here. And if this, this should return us unexpected error now, if we understand everything correctly. That's what I expect to see. But I see nothing. So, what? Okay, can we just do use stood OS Linux ptrace here instead? And stood debug print got word. Like, let's just see what the fuck this returns us. New ret, I guess. There's probably a ret defined somewhere else. Okay, so we got word -2 or FFF2. What is that in human letters? Oh, that's a big thing. Oh, because this returns a U size. Can we cast this to an int64? As I64. -14. Which is what? Which is what? -14. -14. Fault. What do we expect to see here, I guess, also? Obj dump -d, zig out bin debuggy. At, get, or was it? It's a goodbye? Do goodbye. So here we're expecting that at this address, we should see 554889E5. And definitely we're not seeing that. We're definitely not seeing that. But it's also possible that there's like ASLR in play here. It's kind of possible. It might make sense to... How can we test this? In the child, we could print this data to confirm. So here we could say, print me address of do goodbye. And we can print that as a hex. Right? And can we print the content? Content of do goodbye. And this will be oh, maybe that's not legal, but we can try. So do goodbye as a U8 pointer. And then we log this as content 0 to 4 or something. I don't know if this is legal, but we find out. That looks maybe right. Can we print it as hex and do like a stud mem as value, bytes as value, I32, and print as hex? Bytes as value gives me back a pointer probably, so I can dereference it. Okay. Can we do it as a U32, I guess? Maybe makes more sense. Okay, 5548895. Obj dump. Do goodbye. 5548895. 5548895. So it looks like from the child, we are at the very least know that in our address space, at this address, we are seeing the value that we want, right? So ASLR shouldn't be fucking us there. Maybe we need peak text instead of peak data. I mean, I thought they were the same, but I mean, it is reasonable to say that we should try that, huh? Does seem reasonable. And then we need to adjust the function pointer now because it moved, which is fine. Program counter at this exiting parent. Oh. Did the entry point move as well? Okay, initializing breakpoints, got word -14 again. So, yeah, this is weird. This is weird indeed. Peak text. What am I even getting back? It was fault, right? How to interpret the peak text return value? The code you included is somewhat unconventional. I'll explain what it does and show a different way to do it. Features on Linux returns a long, not unsigned short. Okay, just give me the answer. So he gets a long ret. Primary and secondary. What the fuck? Okay, sure. So he's calling peak text at the instruction pointer, but we don't want to do that. We want to do whatever we loaded. primary and secondary opcode bytes. Sure. So I feel like we're just not getting, like when we call peak text though, it's not returning anything sane for us at all. Right? Am I crazy? It's returning like an actual problem. Ptrace rec PID address data adder 2. Yeah, I feel like I'm missing something like kind of obvious here. Can we probe at like the current address? Will that give us anything different? No, just still negative 14. Man, pretrace. Return. On success, the ptrace peak operations return the requested data, but C notes. The ptrace seccomp get filter operation returns the number of instructions, blah, blah, blah. On error, all operations return -1, and error no is set to indicate the error. So I'm actually not getting error no. I'm not getting -1. Right? Like, I'm just getting -14. Which is also kind of fucking odd. Very strange. Very, very strange indeed. Yeah, I mean, that's very clearly not what we want. And it's also weird that, like, doing different addresses here doesn't change the value of the return. In the man page, it had a ret for efault. Looking. There was an attempt to read or write from an invalid tracer in the tracer or trace's memory, maybe because it wasn't mapped. Possibly, but like if we are at the start address, right? We are at the address of start. How could the program not be mapped? Oh, maybe because it's like the loader hasn't loaded everything in yet. Possibly. But then again, like also it's weird that it's not coming in an Erno. Can I like std OS Linux? Oh, we're kind of bypassing libc as well, which kind of adds complexity here. Right? So it could be that like Erno is a libc concept, not like a Linux kernel concept, which means that like the returns from ptrace might actually be something different at like the Linux kernel level. So can we look at like, do we have Musil checked out? Is there like a ptrace? See, stood Linux ptrace. Okay, so this calls the syscall. Who sets Erno here? Erno equals. So he calls syscall here, which is from syscall.h. Which is going to be annoying. I assume X here is for x86. Who? Oh, this is probably like a define syscall, probably. Yeah. Okay, so here they call syscall ret with syscall with the VA args, and they dispatch this depending on how many arguments it has, which means that syscall ret is the interesting thing here. So we want like long syscall ret. And so they set erno unconditionally here. Okay. So the man page saying that we return -1 and erno is set is not really true here, right? For us, since we're using the syscalls directly, then it is actually just returning the thing that we would have put in erno. Right? That's kind of what this says, if I am reading this correctly. Which is great. So that means that we are actually getting an e-fault. And that I don't understand why, because we are only doing this stuff if we are at the start address and we're trying to read the start address. So how is the start address not mapped? You know? If sounds like a Zig bug? I don't think so. I don't think so. I'm pretty sure that this is nothing to do with Zig here, and it's like I must just not be understanding how this can happen. So can we look up okay. Can we just like stop here for a second? I want to look at like proc PID maps. That's what I want to look at. I want to see what is mapped at this exact point in time. So this is just an I32. So we can say std fs open file absolute, and I guess we want to do like const path buff var, but path buff is a, some space for us to write some U8s into. We have const maps path is going to be std format buff print into path buff of proc PID maps using the PID of PID. Then we can open the maps path. As a file. And then we can read to end. I just want to see what's in this fucking thing. So alloc and 1e9, and we try this, and we get the maps data. And then can we just like std debug print current maps is this. All right. We need an allocator. And we have the GPA is std heap general purpose allocator. Start add is the same as a run fork versus run directly. I don't know what you're asking. Sorry. Don't really understand what that means. Okay, so what I want to know here is if we look at proc PID maps, we should see that the executable is mapped into its memory. Fuck! Somebody here is a whiner. He's complained about maps path not having written try here. Right, so here we do see that this stuff is mapped into memory here, right? So we see that the debuggy has memory from 1034 to 10D08 or whatever, right? And we're trying to read the stuff at 1034A30. So the concept of this stuff not being mapped doesn't make sense to me. And it's like, especially because it's readable, right? I could totally see if it was like, hey, like you're not supposed to be writing this stuff right now, or you're not supposed to be reading this stuff right now, but it's RX. So like, what's the fucking problem? Yeah, I don't understand. Man to ptrace. Ptrace peak text. Read a word at the address adder in the trace's memory, returning a word as the result of ptrace call. Linux don't have a separate text and data address spaces, so these two operations are currently equivalent. Okay. And can we look at like e-fault? There's an attempt to read or write from an invalid area in the tracer's or tracee's memory. From the Linux source code, it looks like it uses the data to return the data. Oh, is there some sort of like... I mean, that would make more sense, right? But it's just like the man page explicitly said that it didn't do that. So I fucking trusted it. I'm down to check though. So ptrace.c, and can we look for like a peak text? Yeah, I mean it really does look like that, huh? Like a lot like that. Could be a difference between libc and the kernel. We could look in Moosel, which we kind of assume for now. We kind of assume that this handles things like in the same way as our libc, but might not be true. I don't see any special handling for peak text here. Right, like they're not doing anything crazy. Yeah. Oh well, I mean, C source at the end of this. No cheating, no cheating, no cheating, no cheating. Yeah, I guess we can trust the Linux source code. I just don't understand why the man page is a fucking lying piece of shit. You know? But you know, it is what it is. I guess. What did we see in the Linux source code again? It was peak text. This data is an unsigned long, which is the pointer. So put user temp, which is also an unsigned long. So it looks like we just want to use a U64 there. That's fucking annoying. Fucking annoying for sure. Okay, so we'll say var ret is a U64, or var current data, and we will use the BP addy here again, and we will pass in current data here. Although it doesn't really explain the e-fault. Oh, but it could explain the e-fault if it was trying to write to data that wasn't there. Let's look there again. Linux ptrace. This was peak text. Put user. Is this a define or a... Yeah, okay. So it looks like the e-fault is probably from us passing a null pointer to the data, which is kind of funny. So now we should actually see that got return here should be fine, and got data should be no bitcast here of just current red or current data. Fuck. Expect to use, so we need int from pointer here. Yeah, 554889E5. Those are the numbers we expected to see. Oh, fuck you, man page. Fuck. Okay. That's okay. It's okay. Everything's fine. Everything's fine. Let's say we'll split this stuff into a kind of function print PID maps, just in case we need this again, which we probably won't. But just in case, we'll just slap this here. I guess this needs an allocator. Which we, I guess, don't use anymore because this thing is unused. And here we need a const allocator as equals std mem allocator. Chillin'. Okay. So now we go back to reading the register. If we're at the start address, then we set up our breakpoints. And now we can go back to what we were trying to do, which was reading the existing thing, saying current data and 0xff is equal to 0xcc. No. I want std. See library kernel differences at the system call level. The ptrace, ptext, and ptrace peak data and peak user operations have a different API. Where are you seeing this from? See library kernel differences. Was this in like the man page? Did I just miss it? It's in the man page. Oh, I'm gonna fucking lose my mind. Okay, thank you. I should have. If only we had read the thing top to bottom. Okay, good eye. glibc wrapper specifically. So probably the fact, I bet you, like the fact that we checked it in Moosel, I bet you Moosel just has different behavior there than libc maybe, glibc maybe. That's like a very real possibility. Although I would expect them to have like one-to-one compatibility. Or we just didn't find it in the Moosel source code correctly. All of those are options. Oh, but that's okay. Thank you. God, it's so nice having like, it's like, I was telling my friend that it's like, it's crazy to see like, I'm working, like, how do I say this? Sometimes like you guys just like know stuff, which is crazy. And it's just like it's really great. He's like, it's like pair programming individually with 150 people at once. And I'm like, that is kind of what it's like. It's just like sometimes you guys just give me the right answer. It's pretty sick. How do I bit mask off the bottom 8 bits? Am I fucking stupid? I want like the inverse bitwise not of 0xff. Or 0xcc, right? That's what I want here. And then I just send that shit back, right? So we do, so I guess we don't need this like OS Linux ptrace anymore. This can go back to std POSIX ptrace, which has the nice little try API for us. Then here we can try poke text. And we just put the shit back. And now what we expect to see is when we continue, we will see it run to that point, and hopefully we'll see an int3 instruction executed, and we'll get a sig trap propagated to us. So we should see program counter at this address, and then a crash or something, because like we'll have like fucked up the executable. Fuck! Instead, it just never works. It never works because this thing should not be here anymore. Cannot perform binary not on this. Fine, so we say as U64. And program counter at content. Okay, so we have address of do goodbye. And then we have 10352F0. Program counter at 10352F1. Ah, okay, wait. That's actually really good. So we are 1 byte off from the expectation. But that's okay because that just means that it already finished executing the int instruction. So that's really good. Didn't you just replace the old data? Yes, that's what I wanted to do. So if we uncomment that poke text, we see like content of do goodbye, goodbye, exiting parent, right? Here what we're doing is I'm taking like the instruction that is at like this address in memory of like where the the do goodbye function is. And we're saying like replace the first byte of that do goodbye with an interrupt. And so now we see that we get like a program counter here, but then probably like the child process just like blows the fuck up, right? We're not logging like why we're exiting here. But here we could probably print the ret value here, and it will probably give us a clue. It'll probably be like child is fucked as fucked, you know? Status 1 PID. Can we see like what the signal of the child process was? Right? ptrace gets a thing every time we get like the ptracer gets a wait PID result on every single thing that happens. I guess we will see if we just run a ptrace cont here before we crash. Does that do what we want? And that it will like show us the like disaster signal that the child got? No. I want to see like status 1 wait PID result man2 wait PID. Okay, so meaning wait for the child whose process ID is equal to the value of PID. Oh, that's the value of PID. I want the we're probably getting like signal here. I want like is there a way to get like which signal was given? You know? So this will say is we were signaled if we were terminated. Exit status. But I want like the signal that it threw. ptrace get signal. Oh, maybe it's man2 ptrace signal. Get sig info that caused the stop. So that seems promising. We could try that. But it's not stopped, which is also confusing. So I think that it's probably just like hard crashing, and that's just not returning to us that way. We could try it though. We could try it. Stud POSIX ptrace. What if we modified the executable? Oh no, it's just that the child doesn't handle sigtrap anymore, so there's no reason for it to continue. Okay, that makes sense. So it says like sigtrap, and we go, okay, go ahead, buddy. And then what does this like 0 mean in cont again? If data is non-zero, it is interpreted as the number of signal to be delivered. Otherwise, no signal is delivered. Ah, so here we need to propagate the signal that we got. So here we need to call stud POSIX ptrace with get sig info. This is a sig info t structure from the tracee to the data in the tracer. So where do we get a sig info t from? That's going to be in like stud os linux sig info t. Yes. Okay. So we have like var sig info is equal to this thing, right? I guess it's more like it is one of these things, but undefined. And then we say, could you please send me back one of those things? I think that it was adder is ignored. Yep. Then we return this back with sig info t signo. And so now we should see that the child aborts with a sig trap that it doesn't know how to handle. 55. Fine. Int from pointer. Fine. Fine. And signo. Int cast, I guess. So here, it's just, we're returning execution, and he's like, bitch, I don't know how to fucking run that thing. So he's immediately signaling again. And then we are being like, no, I promise, go again. It's like, no, I really don't know what to do. So here we should only do this. Here we just need to like crash, I guess. No, I'm a little confused actually. I'm a little confused. So we're constantly running that same fucking instruction. But like somehow there must be a way to break out of this, right? We go into his signal handler, he doesn't handle it, it comes back to us. How do we know if he tried to handle it or not? I guess the only thing that we care about is sig trap. So if it's not a sig trap, then we crash him, I guess. No, I'm missing a piece here where like where we need to let like Linux catch the signal and crash the program in the way it normally would. Which kind of makes me think here that like if it's not something that we expect it to handle and we send it back, no, I don't understand. I don't understand. Right? Because like when you run a GDB and it segfaults, it like manages to exit the process somehow. But we are never exiting the process because it just keeps signaling back to us and we keep signaling back to him. I think maybe we should print out what signal we got. Sending back signal this. Hello? Why is that all of a sudden doing what I wanted? Maybe we just forgot to compile last time? No? Okay, another one of these fucking weird things where adding a print is completely changing the behavior. Which is fucking annoying. Fucking annoying for sure. Yeah, that's very strange. Is this another one of those things too, where if I like take out the new line? No, that's fine. So this time just printing it worked. Is there like some sort of like bullshit optimizer thing where here he thinks that it's undefined, so he can't propagate him or something? There might be something odd going on there, and this read forces like some strange behavior. I can't justify it any other way. Are there like zig rules on like this like int from pointer thing? Maybe add a volatile or something? Is that like a word I'm allowed to use here? Doesn't really feel like it. Yeah, there's something odd here. I don't know what it is, and I'll have to come back to it at some point. But for now, I think I just want to keep moving. Pile on to the pile of shit. I'm not certain I know it exists though. Zig volatile. Volatile. can be used to denote loads or stores of a pointer that have side effects. See also volatile. I guess maybe like you can like attach it to a pointer. Yeah, I'm not really sure. I'm not sure. Like here, maybe you do something like sig info pointer is a volatile pointer to this. And then you cast this. And then here we say read from sig info pointer or something. Just got back, what's the problem? We're seeing like different behavior here if we print the signal that we got back here. So if we say like, hey, get the signal that this guy sent to us, then send it back. If we do that with a print, he like, the child like ends like I would expect. And then here I comment this out and we just get like stuck in this loop and I like don't understand why. I don't understand why. And we saw that before earlier with this print maybe. It could be maybe that you need to wait a little bit for ptracecont. ptracecont. Restart the stop trace. If data is non-zero, is interpreted as the number of signal to be delivered to the tracee. No, I don't know. Death under ptrace. Oh, here we go. When traces report their death to their tracers. Note that the killing signal will first cause signal delivery stop on one tracee only, then only after it's injected by the tracer. Is it dispatched to a thread which isn't traced, which death from signal will happen on all tracees. Sig kill does not generate. Okay. If the ptrace O trace exit option is on, ptrace event exit will happen before the actual death. This applies to exit via exit and the signal death and signal deaths. The tracer cannot assume that ptrace stopped tracee exists. There are many scenarios where the tracee may die. Sure. This doesn't really explain like only after it is injected by the tracer will death from the signal happen on all tracees within a multi-threaded process. Term signal delivery stop is explained below. When a process receives any signal except sig kill, the kernel selects an arbitrary thread which gets a signal. Okay, sure. At this point, the signal is not yet delivered to the process and can be suppressed by the tracer. The tracer doesn't suppress the signal; it passes the signal on to the tracee in the next ptrace restart operation. The second step of the signal delivery is called signal injection. Sure. Signal delivery stop is observed by the tracer as wait PID returning with whiff stopped true, with the signal returned by W stop sig. If the signal is sig trap, this may be a different kind of ptrace stop. If it returns a stopping signal, this may be a group stop. Oh my god. Oh my god. Process to enter group stop. The side effect happens. Okay, what is like group stop? When a process receives a stopping signal, all threads stop. If some threads are traced, they enter a group stop. Blah, blah, blah. Therefore, the recommended is perform the call, get sig info. This call can be avoided if the signal is not sig stop, sig t, blah, 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 blah. If the tracee was attached using blah, blah, blah. Okay. Kernel behavior. Be used to restart the tracee in a way where it does not execute, but waits for the new event. It feels like there's like some sort of like loop condition here where like what's really bothering me here is the fact that this print changes anything, right? If it was like every time we send the child a signal back, it just like wakes us up, I'd be like, that makes sense. Right? But instead, what's happening is like we print and then that's not happening. And it's like, what the fuck is going on? You know? ptrace debugger example. We like, what was that link that I said was cheating earlier? Why would the child stop again after const? Because it's like, it's if we're sending it back, like my thought here is we have inserted a trap, right? He executes the trap and then we say continue without fixing it, right? And so then he's just like executing some garbage data and is gonna like sig bus or something. He's gonna like get some signal that's like, fuck you, I don't know how to execute that, and should crash. But because it gets like a signal, we like get notified of that thing happening. And we go like, okay, propagate that to the child. And the child goes like, oh, I can't run that again. Right? Like, because the program counter hasn't moved, he's just gonna like try to keep going and then fail. But then like I don't understand here, if we send the signal back to the child, that's when he should go like, oh fuck, we die now. Right? And the signal shouldn't be handled in the child, and so I'm missing something about like, I would expect him to crash here. I would expect him to crash. But then it's only kind of doing that if we print the signal before sending it back. Otherwise, it's not crashing. It's just railing us like this. And it's like, what the fuck is going on? I guess maybe here we're getting like the same thing back from wait PID. You're not checking for if exited? Yeah, okay, that makes a lot more sense. That makes a lot more sense. So if we are exited, we should print child gone and return our break. But like here, I just don't understand why, like, shouldn't we be in the same I just don't see why this is different if we print or not. You know? If stopped, if signaled. Term sig maybe? What is term sig? Term sig returns the number of the signal that caused the child process to terminate. So W if signal. Let's try that. Let's try that. No. If signal, so it's like, no. Okay, we're checking if it's not stopped. If it's anything but stop, we quit. So we're getting like a constant stop signal back from the child over and over and over again. And then we're trying to continue with the signal number, and we're just getting another, we got a stop back. Unless we print the signal that we got, which is just so confusing to me. Then we get the child signal quit. It continues. So my gut says that there's something funny going on here. It's like, it feels like the only reasonable explanation. But I can't really justify why. Right? Like, if Zig's optimizer, like if Zig somehow just thinks that this hasn't been modified because of this int from pointer thing here, You're getting sig stop back from get sig info, right? I don't think so. We're getting, let's see, signal 5. Man 7 signal. It doesn't tell us the numbers. God damn it. God damn it. Can we go to like std os linux and signal? Do we not have like stop in here? Signal, here we go. Sig, we're looking for sig. We're not MIPS though. If MIPS, else if spark, else. So we're sig trap. Oh, we are getting sig trap over and over again, which is kind of interesting. I would have thought. Oh, so it's just re-executing the same fucking trap over and over again. Oh, okay, maybe that's sane. So now I'm back into like the fact that it's different. If we read the signal or not is very confusing to me, right? We get a sig trap, we propagate that back to the child, and we expect the child to die because of that, because he doesn't have a signal sampler, right? If we look at debuggy, there's no signal handler set up, so he should crash when he gets a sig trap. And instead, like, nothing? Only when we don't print? Which makes me think that we're not sending a thing back. Okay, let's try this. Let's just hard send back a 5. Interesting. Doesn't ptrace attach to a sig trap handler in the child? So you think if we send back anything else here, like, no. So I keep going back to the fact that if we print, the child crashes like I would expect. That's where I keep going back to. It's like if we answer him too quickly for whatever reason, it's a problem. Like, that doesn't make sense. That doesn't make sense at all. Okay, like, let's just see time sleep for, 500 milliseconds. Do we think that gives it the same behavior? So we, what is it? Sleep is in nanoseconds. So let's sleep for 1 second. Nap time. Let's just see what happens if we do that. Nothing? That's even more confusing. That's so much more confusing. So here we don't loop back. Here we wait for the next iteration. And what? We get like nothing back? Yeah, we're just stuck in wait PID? How's that reasonable? Oh, I guess we only want to do this in this other branch here. In this branch, we kind of want to continue with no signal propagated, which might be kind of interesting here in some way, shape, or form. Right. Okay. So this makes sense. We say, let's set our breakpoint, and then we'll nap again. He hits that breakpoint that we set. We go to sleep for what feels like an eternity. wakey. Oh, okay, now this makes more sense. Then the child seg faults. Why is this only getting printed sometimes too? I don't really understand. Segmentation fault at address for the child. But either way, we get like a exiting in this case. Okay, so now let's not do that. Spamming got return and program counter. Yeah, there's just something really weird where like the timing of this seems to like be really relevant in some way. Where like we either get in the state where wait PID hangs or returns the same event again. And neither of those make sense. The trace will be notified at its next call to wait PID. That call will return a status value containing the information that indicates the cause of the stop in the trace. When the tracee is stopped, the tracer can use various ptrace operations to inspect and modify the tracee. The tracer then causes the tracee to continue, optionally ignoring. I'm trying to remember the semantics of cont versus restart. I thought you normally want restart unless you want to suppress a signal. I don't see a restart in here. Unless you're talking about like in GDB. In GDB, you're supposed to do like continue keeps going and restarts the app. But I don't think that's what you're talking about. I would try to replicate the problem in C just to rule out a Zig issue. Yeah, that doesn't seem crazy. Doesn't seem crazy. Because it does feel like it's like the caller side is causing problems here. And the caller side, like the parent, yeah, it does just feel like he's. I don't see what the Zig issue could be though. That's the thing, is like I'm just so. If we reprint like just another program counter at, then it's fine again. Yeah, there's just some sort of timing thing, it feels like. I don't have a good answer for it. All right. Well, I mean, maybe since I don't have good leads, I don't really want to rewrite it in C right now. I might rewrite it in C off stream. I don't think that's like a particularly interesting endeavor. And I will maybe see if that fixes it or not. But if not, we'll have to figure something out. So we have not got back to the point where we can continue from a breakpoint. I would like to understand this. So I'm going to call it here for today. I think we made some good progress. I think we understand a lot more than we did at the start of stream, but we're definitely not all the way there. So we'll be back at it tomorrow. Okay. Thank you for watching, guys. If you liked what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. If you're watching on YouTube, you're seeing the 2 to 4 segment probably, which means that you might be wondering, there's 12:30 segment that you're talking about. What is that? And that means there's a kind of like less focused, vibier session that goes on 12:30 to 2. Today we were investigating the Linux kernel graphics stack. We might do a little more of that tomorrow. If you're watching on Twitch, there's a YouTube link in the Twitch description where you can swing by and see what we've worked on in the past. I've got the swing by is usually I say it the other way. YouTube, you can swing by on Twitch if you want to check us out live. Twitch, there's a YouTube link in the description where you have all of our previous projects organized into playlists, and a GitHub link in the Twitch description where you can see code for this eventually. I will put this code somewhere, but it doesn't have a repo yet because we just started it just now. What else? I think that's it. Like, subscribe, Twitch Prime, and YouTube, goodbye. Twitch, let's find someone to raid. LCQ.